All right, so we switch our x's and y's, and then we solve for y. So what's the first step now that I have to multiply by what? Y plus 3, you mean? You want to get this out of the bottom, right? So you want to get the y plus 3 out of the bottom. Okay, so you have to multiply. So I've got, let's distribute that too then. xy plus 3x equals 2y minus 1. Okay? So again, my goal is to get y by itself. So I got to get the y's together and everything else on the other side. So do you want to take the xy over the 2y, or you want to bring the 2y over with the xy? Doesn't matter. Your choice. Carly, what do you think? You want to bring the 2y over? Yeah. Okay. So we'll subtract it over. And since the 2y's and the xy are over here, let's take the 3x over. So I'm going to do 2 steps at once here, just to get the y's on the left and everything else on the right. Okay? So xy minus 2y is just that. Oops. And then negative 3x minus 1 or negative 1 minus 3x, it doesn't matter. Okay? So again, I took the 2y over the left side, the 3x over the right side. Now, what did we do at this point yesterday? Remember, we're trying to get y by itself, and we have 2 y's right now. How do I turn it into 1 y? What did we do yesterday? I told you later because I forgot to show you this. Okay, I told you, look up here and say it again, honey.
GCF.
GCF, yeah. Treat y as a GCF. Factor it out. So these two become 1 because they're common to both terms, right? So then this is just x minus 2, right, when I factor out the y. Now, how do I move the x minus 2 over? Because this is y times that, right? So I have to do division. Okay? So the y minus 2's will cancel. So I got my y, or we could say it's f inverse, right? We're finding inverses of functions. And then negative 3x minus 1 over x minus 2. What's my restriction? What is x not allowed to equal? 2. The original problem, x was not allowed to equal negative 3, right?
That's it.
Is that all that happened?
Swap signs, I think. One sign.
Okay. So,
There's gotta be a shortcut.
no, there's really no shortcut. All right, so we're swapping x's and y's and solving for y. Sometimes like this, you're going to get more than one y, so that's why you got to get them together and then factor it out as a GCF. Okay, so those are the harder ones. You can do that, you got this. The other ones were really pretty easy. So looking at our answers for homework, number 31 was 1/2 x minus 2. 32 was 1/4 x plus 2. 33 was 1/3 x plus 7/3. 34 was negative 1/3 x minus 8/3. Any question on those? Those should have been pretty easy for you. 35, negative 1/2 x plus 5/2. 36, negative x plus 3. Exactly the same. 37 was x over x minus 2. X cannot equal 2 is our restriction on our variable, our domain. Thanks. Yeah, you're back now. You're a wanted man, huh?
What'd you say?
38 is 2x over x minus 1, so x cannot equal 1. And the last one is x plus 1 over 1 minus x, or you could have had negative x plus 1 in the bottom if you want, and x cannot equal 1 for that one. So 37, 38, 39 was similar to this one. Any of those you'd like me to go over? So again, when you're trying to find an inverse, you're just swapping x and y and solving for y. Okay? When you have a variable in the denominator, like here, then you got to figure out what your restriction on your domain is. Okay? Because we're not allowed to have the domain be a 0. Can't divide by 0. Okay? Today we're looking at some exponential function stuff. All right? So, when we have a variable in the exponent, we call it an exponential function. All right? So our example is f equals 3 to the x power. So what's f of 2 mean to do? 3 what? To the second. So what's that answer? 9. That's tough, right? F of negative 4 means 3 to the negative 4. Well, you guys remember, we don't like negative exponents. We like that's positive. But either way, you can just put it in your calculator, put the negative or 1 over. Okay? But remember, we don't like showing negative exponents. Okay? So you could do this if you want. 3 caret negative 4. It's going to give you a decimal. I would do this, though. Math fraction. Okay? But the decimal's okay. It's not wrong. Okay? 3 to the 4th is 81. What about this? Can we do that? Sure we can do that. All right? Where's pi at?
In my fridge.
Yeah? Sometimes. You guys see where the pi is?
Yes.
It's by your caret button. So hit second caret, and then get that. You can leave it the 31.5, or I don't know if it'll give us the fraction. It might not. Math, enter. Yeah, it won't give us the fraction because pi's an irrational number. So on those types of problems, you're just substituting the number in for x, putting it in your calculator. So it's all substitution stuff. Okay? Now, when they talk about the natural exponent, exponential function, that's that e value. Okay, we talked about it a little bit last year. And again, we'll talk about it a little bit this year. But that's on your calculator as well. Okay, there's 2 spots. It shows up. If you look at your division sign, let's clear all that out. Hit second divide, it gives you that E, and if you hit enter, it'll tell you that 2.71828 number. And it's a number like pi. It goes on forever. It's an irrational number. Okay? So you have that. But the one button you want to use is the LN button, second LN, because you're going to get some word problems with some formulas that have e to a power. So when you hit second natural log, it goes e to the power, and then you'll plug in whatever you need to plug in. So that's what you want to hit, second natural log. Okay? You know, if I put it to the first power, that's e. That gives us that same answer. Okay? But you're going to have different powers for that. You're going to get a problem that looks like this, and you're going to use that E value from your calculator, okay? So it says a cup of coffee is heated to 160 degrees Fahrenheit and placed in a room that maintains a temperature of 70 degrees Fahrenheit. The temperature, capital T, of the coffee in degrees Fahrenheit after little t minutes is given by that formula or function. So as you can see, there's an E here, raised to this power. So the little t is the number of minutes. You know, if it was after 10 minutes, you put a 10 there. If it was after a half hour, you put 30 there. Okay, capital T is the temperature of the coffee. Okay, so it says find the temperature of the coffee. So I'm looking for capital T to the nearest degree 20 minutes after it is placed in the room. So my little t is the 20. So all I'm doing is putting this in my calculator. 70 plus 90 E caret, all right, and then it's negative 0.0485. Now don't just put 10 there, you need to put times 10, because that means times t, right? But not 10, because it's not 10 minutes, it was 20 minutes, right? So times 20. So you need to just plug it in and get the answer. Okay? So just put it in there. Let's just clear this out. So 70 plus 90, hit second natural log for that e to the power to pop up. Okay? And it's on these calculators too. Somewhere, let me find it. It's got the ln button also. So this second ln on second natural log. That's how that came up. And then I got the negative 0.0485 times 20 and close up my parentheses. Okay? So after 20 minutes, the temperature of my coffee is 104 degrees. Zach.
The 90 is that part of the equation, or is that?
That's part of the equation, yeah. They will always give you the equation to use for the problem.
Okay, so it won't always be 90.
No, it won't always be 90. They'll give you different formulas, I guess, equations to use. Okay, so all these word problems, they'll give you the formula. All right. So that's how much the temperature is. So the temperature, after we plug that in, is 104 degrees. It's probably still kind of hot to drink, isn't it? Okay? Yeah. So here's the other thing you got to do. Determine when the temperature of the coffee will reach 90. Okay? So we haven't figured out yet how to solve for T. You know, if we put 90 here, I'm going to show you eventually how to solve for T. But since I haven't showed you yet, here's what you should do for this part. Put this in your y equals that formula. Okay? So you're going to go 70 plus 90 second natural log, and then negative 0.0485. And since we don't have a t, we're going to use x, and then close it up. All right? And you can hit graph. You probably won't see it, but that's okay. Okay. Go to your table. All right? How do I get to the table? Second graph. Okay? All right, so at 0 minutes, it was 160 degrees, right? Isn't that what it started out as? Started out as 160, right? So when you go to your table, all right, you're looking at the y's. This is your, this is the y answer here is your temperature answer. So you're going to go down through this, until you see, what were we looking for again? What degree? 90, yeah. So I'm gonna go down and look for 90. Hunter,
My calculator just says 104.
the whole time?
Yeah.
Okay, so you typed something in wrong. All right. So we just keep going down till we get to 90 in the Y. Again, you guys can hold it down. So 31 minutes is what you would do there. So if you're looking for when it reaches a certain degree, put it in the Y equals. Right? And you put all this in, okay? Second natural log. And remember, you don't have a T, you're just gonna use X right here. Okay? Close it up. Did you remember to close it up? Did you put negative 0.0485? Okay, I'll look at that. Okay, and then go to your table, and your table will find that degree there, your 90 degrees. All right, we're looking for that one. Okay, so the word problems are easy. Okay, you're just going to plug in. If it asks, gives you the amount of time or whatever it is after so many years, or all of them are a little different, but they'll give you the formula. You'll have to do this E, which is second natural log, to plug it in. Okay? And that's basically it today. You're just plugging in using your calculator. All right? You're going to have problems like this, where you're just plugging in, use your calculator, and you'll have a couple word problems today, like this, that are similar. All right? So it's really not a very tough day. So there's your assignment. Hunter, I'll help you out here.
I ain't know what's going on, please.